So welcome back. Again, you guys know me, I think, Aaron Salzberg, Director of the Water Institute. I'm really excited about this session. You know, the tech sessions were always kind of the highlight of the week, and they just became packed, and the rooms began to grow, and so we've decided to make this a bigger part of our program. So we're really excited to be able to do that, and I always think it's fun to see all the gadgets and everything else, so I think it's great fun. I really do want to thank our sponsors for being able to do this, Business Connect and everybody else who's made this possible. Bart, you can go ahead and click. The slides yours or mine? There we go. So again, thank all those conference sponsors who've helped enable this and make this to happen. Business Connect, who really allowed us to pull this event off. We're really excited about that. Just to give you a few words about how this is going to work and what it's about, what we're looking for is what are some of the coolest, newest, innovative technologies that are out there that might allow us to address some of the challenges that we're talking about, throughout the week. And we're really excited to have lots of presenters come up. They each get a 5-minute pitch to pitch their idea, and all of you get to see it, and we'll judge those pitches. In fact, we've got a great panel of judges that I'll introduce in a minute that'll be reviewing each of these individual pitches. The idea is that on Thursday, we'll announce some awards for the 3 technologies that we think, one is the most innovative, the second that has the most impact, and the third that we think is the Audience Choice Award, and that'll depend on all of you guys and all of your voting. The Innovation Award, as you guys can see, will recognize a solution that introduces a novel approach. The Impact Award is a technology that we think can actually address a problem at scales with thought to the broader, a broader application. Of course, audience is the results of the polls. Each one of these will be judged on 3 factors, and that's the next slide, I think, Bart. Thank you. On 3 factors. Is it? Oh, no. These are the awards. Sorry, these are the awards that the winners will actually get. And they'll actually get consultation time to help develop their product, and with the idea of bringing their product to market and being able to develop that product. So we're really excited about that, and I hope it's exciting as well for our technology providers. These 5-minute presentations technologies will be judged on 3 different areas. One will be on impact and its significance to the problems that we're talking about. 2, scalability. And then 3, sustainability. And each of our judges has a rubric in which they'll use to kind of work through and rank and grade all the different presentations. Without further ado, I'm going to introduce our distinguished panel of judges. And Edgar, please forgive me in advance. Edgar Niaboya, sorry, I am going to get this. Edgar Niaboyamahina. Almost? I was close? Oh, thank you. I'm so sorry. From RTI, he leads operational excellence at RTI, and we're really excited to have you here joining us today. And let's see, Jeremy, of course, which I was surprised to learn. I didn't realize that you had 20 years of ministry experience as a pastor. So you can come up here and give next year's opening remarks at the plenary. And that you're also a volunteer with business leadership roles, of course, within Business Connect. We're excited to have you here, and as always at our conference. Mike Fisher, one of our own, Dr. Mike Fisher, develops, evaluates, and applies technologies and methods for addressing under-recognized health concerns in water and sanitation. And of course, William Kamkwamba, who we'll get to know quite a bit over the next couple of days from Moving Windmills. He defies description in many ways. TED Fellow has worked on the Wider Net project, looked at lots of different technologies for bridging the gap between knowing and doing for young people in Malawi. So we're really excited to have William here with us, and especially we will have a moderator, and I'm going to turn it over to Jamie Harris, and Jamie is with Business Connect. She's the head of research at Business Connect, and so I'll turn it over to her, and I'm going to go grab my lunch and sit in the back and watch all the fun presentations. So thank you, guys.
Thank you all so much. Can you hear me okay? Okay. Yes, thank you again to our judges for being here. We're so excited to highlight some technologies and innovations within WASH. Our goal for all of us being here is to alleviate some of the issues in WASH, and these technologies and innovations are the most forward-looking methods that we have to help alleviating this issue. So I'm really excited to highlight some of these innovations. They only have 5 minutes, so each presenter has 5 very short minutes to, I'm sure, describe a very complex and thorough process that they're about to present. So we will be timekeeping and keeping that going. And then after each presenter, we will have 2 minutes of Q&A. So we welcome questions from the audience. We have some microphones up here we can pass around. And if the judges have questions, of course, you can ask as well. But we will be cutting it tight so that way the 1:30 session can happen on time in here right after this. And as Aaron said, we do have an Audience Choice Award, and we do require all of your help in selecting the Audience Choice member. So at the very end of all of the presentations, I have this QR code, and if you don't have a phone, you can just go to slido.com and use that string of numbers. And at the very end, or if you have it now, you can be rating the different presentations, so that way we can have an objective number to select the Audience Choice awardee. So thank you for helping us participate in that. And I think those are all the housekeeping. This is our first time doing this in the auditorium, so we are working out the rough edges, but yeah, we're excited. So without further ado, I can go ahead and welcome our first presenter, Aqua Research, and we can get things started. Okay, thank you.
Okay. Can everybody hear me all right? So I have the dubious distinction of being the first tech presenter of the First Tech Innovation Showcase. All right, well, thank you for your attendance. My name is Rodney Harrington. I'm the founder of Aqua Research, founded the company in 2010. And Aqua Research is synonymous with chlorine. We make systems that convert salt, sodium chloride, to chlorine solution. So we have them in all different sizes. Well, we'll talk about it in a minute. So, the intersection of WASH and infection prevention and control. Water and sanitary health for drinking water or healthcare. We have a lot of systems in various locations on healthcare. So it's a big problem worldwide, as we all know. That's why we're here. Next slide. Okay, and I went too far, back up. I'm learning, okay. So the cost of healthcare infections, it's huge. As we know, there's about 2 billion people on the planet who don't have access to safe water. There's about 3 million people a year die from waterborne disease. That's about 9,000 people a day, half of which are children under the age of 5. So it's a big problem worldwide. And it's chlorine's got issues in terms of supplied chlorine, delivery and logistics issues, the price of it, ongoing logistics to keep providing it. The nice thing about our technology is salt is ubiquitous. Anybody, anywhere can get access salt. So our systems typically make chlorine at about 5,000 parts per million. That's what the World Health Organization wanted for highly contaminated healthcare facilities. You can dilute it down for various other applications. Okay. So there are issues associated with chlorine, as we know. We're talking about commercial chlorine, bleach or HTH, powdered stuff. They're hazardous materials. They take logistics to move. They cost money. Salt is pretty ubiquitous, as I'd said. I'm trying to go through this pretty quick. So we start with salt, a little bit of water to make salt water solution, add energy to it, and then we make a mixed oxidant disinfectant. And this mixed oxidant is primarily chlorine, but a little bit of peroxide. And the combination is a very powerful disinfectant. We kill pathogens of all types. So the benefits of on-site chlorine: it saves chlorine stockouts, it eliminates that problem, improves the quality because it's always fresh, it saves money. It is the cheapest form of disinfection. On-site chlorination is cheaper than any other technology. It improves safety, reduces corrosion and damage to products, and simple operations anywhere. Okay, we have products of all different sizes, and this is the smallest one. We've been selling this thing for 10 years. I've been here at this show for conference for 10 years promoting this thing, but I'll make a tall statement about this. This will provide a family of, small family, 40 liters of water a day, safe water, for 10 years. And all it costs per year is one container of salt. It has a solar panel on the back to power it, has a rechargeable cell phone battery or USB recharge. You get these devices and you've got 10 years of safe water. We have the stream system, let's see here, right here, which we use in a lot of healthcare facilities in Africa. The next one is Spring, and it's a fully automated version of the stream. So it runs continuously, and these other larger systems, AR series we call it, and the K series, are for very large commercial applications. For instance, the one on the end, we have 5 of those operating in 5 of the major cities in Haiti, providing volumes of disinfectant for 168 healthcare facilities in Haiti. That's under a USAID project. All of these systems can be monitored with software, GPS and Wi-Fi communications. This is a screenshot of several systems operating in Africa and locations. So they're all monitorable off your cell phone or your computer. This is an example of USAID program in Haiti, as we talked about, producing volumes of chlorine at 5,000 ppm in these containers to provide chlorine solution for 168 healthcare facilities in Haiti. So that's my story. We are on-site chlorine generation. We have devices, that's primarily what we do, and our primary focus is on healthcare in developing countries. So, thank you.
You can stay up here. At this time, we will open it to 2 minutes of Q&A. So I have a microphone. I think I can maybe, Michelle, if you could come grab this. Oh, thank you. We could pass the microphone around. So you're welcome to, thank you.
I want to get some audience questions, but for folks who aren't aware, which aspects of mixed oxidant generation for these applications are novel to your work, and which aspects predate your work? Just so folks know, hey, what's new here?
Okay, so this technology really came out of a program with DARPA, Defense Advanced Research Projects Agency for the U.S. military. And we had the benefit of a lot of taxpayer dollars, we appreciate it, to help develop it. But they were looking for something that would kill everything, maximize it. So we did a significant amount of work using polymerase chain reaction to kill cryptosporidium. And we could optimize the process, the design of the systems, to produce not only chlorine, but also a little bit of peroxide. So the combination is a very potent disinfectant. We have done many studies on bacterial, both virus, bacteria, and protozoa inactivation. So all that's available if anybody wants it.
Yep, we have time for another question.
This is really very interesting. Thank you very much. Can I ask, who are your main clients and how are you planning to scale?
Excuse me,
Who are your main clients?
Okay, our main clients are the non-government organizations. We're working with many NGOs like PATH and Catholic Relief Services and World Vision and Global Communities and Operation Blessing, many NGOs worldwide. But we also sell these direct through Amazon and through our website. And there are a lot of campers, hikers, preppers, people in disasters, You donate, we've got an organization in Vermont just donated a bunch of these to disaster relief here in North Carolina, as a matter of fact.
And do you have any plans to make these products available in the global south
In
through a
global health,
market-based approach? In Africa, are you planning to make these products commercially available in Africa?
yes, absolutely. We have distributors set up in some areas now. We're working to accelerate that activity. And we have a number of these systems operating in Ghana, Uganda, and Ethiopia under a PATH program with Catholic Relief Services, World Vision, and other countries over there. So yes, our intent is to get this distributed worldwide. And the technology of various sizes is operating in lots of different places.
Great. Thank you so much.
Okay?
Yes, thank you.
Thank you.
Thank you. Oh, yeah, I can get a quick question in.
Yes, thank you. Can this technology or product be manufactured in Africa? And
Yes, it can.
can you source all the parts in those local geographies?
You're asking, can it be manufactured in country? Yes, and our intent is to do that. We have 2 other locations right now that we're trying to introduce it. We just need the right partners in country that we can work with. But there's a lot of taxes going into these countries that can be mitigated by local manufacturing, and we're open to doing that.
Okay, thank you.
Thank you. Thank you so much. Next, we are excited to welcome Clea Electronic Hygiene, LLC. So if you want to come up and get settled in. Great. Thank you.
I'm just going to sit here. Okay. Hello, my name is Michael Pinn, and I'm the founder of Clea Electronic Hygiene, LLC. And what we're here to talk about today is closing the gap in post-toilet use hygiene. Not a sexy subject, but let's get into it. So our mission is to ensure health and safety through innovative technology to improve the restroom hygiene experience. Well, what does that mean? The problem. The use of toilet paper involves contact with numerous germs. We all know it. The CDC is very clear and vocal about our need to wash our hands after using the toilet. That's well understood. The problem is, especially in public situations, a lot of us, after we've done the required paperwork, still have to put our clothing back on, as well as handle other surfaces, maybe pick up personal property that we brought into the toilet area with us. And then and only then can we go wash our hands. That causes a high risk of contamination to our surroundings, even after we've washed our hands. So our solution, and I have a prototype sitting here if anybody wants to inspect it later. Our device is a toilet paper roll holder that sanitizes the hands as well as the toilet paper during use, significantly reducing the active pathogens that are available to transfer post-secondary toilet use. It uses a negatively charged ions that are distributed through the unit that will disrupt and neutralize many pathogens. Easy integration. The device is easy to just put into any bathroom. It can be stuck to the wall. It can be screwed to the wall. Very simple to implement. How's it work? Well, internally it has a high voltage power supply and an electrode array. That causes trillions of ions to be generated through corona discharge. And as I stated earlier, the fan then directs those ions over the user's hands. It's sensor operated, so it's only functioning when the hands are in close proximity to the toilet paper roll. So with that said, it has an internal battery and can be used with and without an electrical outlet. The battery is designed to last about a month in typical applications. So market analysis. Right now, our research shows there's really no product on the market that does anything about hygiene, hand hygiene, during that high-risk period of when as you're wiping and as you finish wiping, and the point where you can actually go wash your hands. So we think that fills a critical gap. We think there's a potential for wide adoption in many markets, domestically as well as globally, as the technology gets implemented. And another fact is the hand hygiene market between 2022 and 2028 is expected to grow by $2 billion. So it just goes to show how important this is to the world. So where are we at right now? So we're seeking to further validate our performance assumptions. We're in customer discovery. We're putting together prototypes and developing our minimal viable product, and we're looking at different funding options. So if you want to discuss it further, please feel free to contact me, and we'll set up a meeting with you. And that's pretty much all I have.
Thank you, thank you. Any questions from our judges or the audience? Yeah,
Mark Sobson, University of North Carolina. Some pathogens that are fecally shed are extremely resistant to a variety of disinfectants. That includes protozoan parasites like Cryptosporidium, human enteric viruses like norovirus, and other non-envelope viruses, and some of the bacteria such as Clostridium perfringens and other such bacteria, including mycobacteria that are also acid-fast and highly resistant. Does this work against all of those?
That is a question beyond my level of education to answer effectively, but I know that it's effective, or I've seen research that shows it's effective with E. coli, with Salmonella, some other bacteria that are typically found in fecal matter, but I will not stand here and say it will work a broad spectrum. Hand washing is still of critical importance.
Thank you. If you want, there are researchers at UNC and probably other researchers here in the audience that would probably be happy to help you get the answers to the question I posed.
Thank you.
Thank you for the presentation. I had a quick technical question to ask. What type of electrodes are you using in your products, and what is the amperage that is needed to generate those ions? Okay, so the electrodes are just a sharpened stainless steel needle, and the high voltage power supply is capable of about 9 kilovolts, negative 9 kilovolts, and the amperage is on the order of tens of microamps in order to generate those, what's needed. And with that said, this is designed to emulate a cell phone, so in its operation. So at full power operation, it draws less than 5 watts.
And do you have a way to tune the voltage so you basically control the type of ions that you are generating?
Absolutely. That's built into the firmware to keep the voltage at the optimal point to keep the ionization at the correct rate.
Thank you.
Thank you. I think we do need to move on to our next presenter, so thank you so much. Appreciate it. Next, we have Aquagenics here to talk about E. coli water quality field test kits.
I'll just stand over here. I hope this microphone is on. Yep, okay. So I'm Mark Sobson, a part-time professor at UNC, formerly a full-time professor at UNC. I spun a company out of UNC to sell a very simple, field portable, lab-free E. coli test. And that company's been in business for a dozen years now or so. And when antimicrobial resistance emerged as a major global threat, as recognized by WHO, we developed an antimicrobial resistance test for ESBL, resistant E. coli, which is the target that WHO recommends be measured. So antimicrobial resistance is a major global problem. It threatens human health around the world. It impacts humans, the food chain, and the environment. WHO says that AMR is one of the top global health risks and development threats worldwide. Bacterial AMR is estimated to be responsible for 1.27 million global deaths in 2019 and contribute to nearly 5 million deaths. The numbers are probably underestimates. So ESBL resistant E. coli, what is that? It's a common strain of E. coli that has the gene that makes it resistant to extended spectrum beta-lactam antibiotics. So it's referred to as ESBL E. coli. WHO considers this strain a critical priority pathogen to be monitored globally by every country on the planet. And where does this come from? Well, infected feces of humans and animals contain ESBL E. coli most of the time. Certainly wastewater does. And these bacteria can contaminate drinking water sources, wastewaters, healthcare facility effluents, sewerage, food crop irrigation waters, other agricultural waters, poultry and livestock production waters, and recreational waters. So it's important to try and measure this organism. WHO has a protocol for this, which is referred to as the Tricycle Protocol, and it's a One Health integrated approach to quantify these bacteria across the sectors of humans and animals and the environment. WHO recommends countries and other stakeholders monitor for this organism in environmental water samples by using a culture-based method. That means you have to grow the E. coli. That's the preferred way that this should be done. The problem is the WHO Tricycle Protocol requires agar media, a laboratory to do this, and it requires trained analysts. Our approach to measuring fecal bacteria, which we adapted to this particular target, is to do this with our currently existing field kit by adapting it to detect specifically ESBL containing E. coli. So we have Aquagenics E. coli water quality field test kit for ESBL, resistant E. coli. It's a culture-based water quality field test, and it'll quantify ESBL E. coli in a 100 ml sample of water. That's the drinking water target volume that should be analyzed. We don't need any electricity, labs, a cold chain, or expensive, complicated equipment, because you can do all these steps in the field. It comes as a kit with all the necessary materials in it. It's easy to use for field level testing. Anybody can do it. It's easy to learn how to do. And it can be used in low resource settings such as rural and disaster emergency areas. It enables ambient temperature incubation at temperatures 25 degrees or higher, up to 45 degrees centigrade, even if the temperature varies within that range, and you'll get results within 24 to 48 hours, or 20 to 48 hours. Takes a little longer if the temperature is a bit colder. So the kits come, as I said, with all the materials that are necessary. One kit detects the E. coli bacteria in a compartment bag. This is a clear plastic bag that's got 5 compartments in it of different volume that adds up to 100 ml. And when ESBL E. coli grow, that compartment will turn blue or blue-green, and that's the evidence of E. coli presence. The other kit is for counting colonies, and that has a gel medium in it that hardens at ambient temperature. So our test is very simple, it's easy to use, it's deployable anywhere, and there's no comparable or equivalent product for field use. So if you're interested, you can read this paper when it comes out next month. If you can't get it, you can send us your contact information, and we'll send you this paper that describes the test. It's a peer-reviewed independent publication, and you can come visit our table right outside the door here. Thanks a lot.
Thank you so much. And I love the idea of collaboration of UNC with other presenters in this tech showcase that you suggested. So that was great. Yes, we have a few minutes for questions. So any questions for Dr. Sobsi?
Yeah, a quick question on your ideal customer. Is it an NGO, a professional that's doing testing? Is it a monitoring along the way in as pipe systems are going in? Is it at a household level? What's your ideal user of this?
Well, our current E. coli test is sold to anybody and everybody that wants it. That's governments, NGOs, healthcare facilities, people in the private sector who can test their own water at home if they want, or get other people to test their water at home. Our current E. coli test is being rolled out to test well water samples in western North Carolina, where there's been devastation and the groundwater is likely to be contaminated. Our test will work, and we're offering it to those folks with the help of the Department of Health and Human Services Water Quality Division. So pretty much anybody can do this test. It's something that kids can do, schools have used it, and so on. So we already have an established market, and we think the demand for this test will, with the E. coli ESBL version, will be substantial, because this is what WHO recommends be tested.
Thank you. From afar, I also saw a question on Zoom potentially, but let's prioritize the in-person and then we'll, okay.
No, please.
Okay. If we could get that Zoom question to pop up again. Was it a question from a participant? Thank you. Yeah, it's very small. It was more of a comment of, this is already very much available in India through a government project. And that was a comment from Chandra Sikran. And it wasn't really a question, so let's open it up to questions.
Okay.
Thank you.
Mark,
By the way, we can distribute to any, we sell all over the world. So we have an operation here in North Carolina, and we sell to countries all over the world. And we're very good at supply chain expediency.
Mark, very excited to see you promoting this for WHO Tricycle Program and monitoring. Some users are probably going to want to select individual colonies for confirmation, potentially for banking or for molecular work. Would Aquagenics consider developing an ancillary kit to help users who want to be able to take positive compartments or positive colonies and select those for further analysis?
Yes, we've already had inquiries about that, and we have information that we can provide to users currently who wish to do that. But we are interested in possibly creating another ancillary kit, as you suggest, to actually provide the tools so that those who wish to do it can get the colonies out of the compartments or pick the colonies out of the gel bags and streak them onto other media for further analysis, or just bank them for further analysis by somebody else.
Great. I think right behind here we had a question. Thank you.
Thank you very much. I'm working in South America, in Ecuador, and we are working in
Where?
Ecuador, South America.
Okay.
And we have different kinds of municipalities. We are working with indigenous people in 4,000 meters above the sea level,
Yes.
where temperatures are lower than 5 Celsius degrees, and also working in the Amazon jungle as well, with temperatures above 40 Celsius degrees. So my question is, first, do you have experience working in this kind of environments with this product?
Yes, we have, and we have an incubator that would, which we could sell, that would control the temperature within the desired range, and we sell that as part of the offerings that the company has.
And the second,
It's a battery-operated incubator.
oh, okay. And the second question is, do you provide some kind of training as well, or are you only sellers?
We have online training, and we're always, we have videos as part of our online training at our website, and we also will provide additional technical assistance to customers who reach out to us, because we have someone on staff who's there pretty much 24/7 to answer questions and address any problems or issues that users have.
Thank you. Thank you so much. Yeah, I think we'll transition to the next one now. So thank you so much. We appreciate it.
If someone else has a question, I'll be around, so
Yes,
by
there
all
is
means,
an
come see us.
Aquagenics booth that is helpful.
Yes.
Yes, thank you. Thank you. And before I welcome this next one, I did just want to remind for people trickling in, there is an Audience Choice Award for all of the tech that are presented today. So you can access that either at this QR code or slido.com with that chain of numbers. And it will ask you to help us objectively rate from your audience perspective. So yes, take notes if you need to so that you remember at the end of it who said what. Next, I would love to introduce Akyas Sanitation, the next presenter. Thank you so much.
Thank you, everyone, for attending the presentation. My name is Bara, and I'm going to walk you through the effluent divergent unit. Simply, we transform pit latrine from containment unit into on-site treatment unit. So everyone and 4 people in the world uses pit latrine. Pit latrine is designed to act as a containment unit. So when we flush something in the toilet, everything is displaced inside a pit under the ground. But hidden is not really clean. Usually the pit often leaks, and that's either because you have bad lining or the lack of proper FSM. If we want to provide safe sanitation to the world, we need to find a way to change this pit latrine, to transform it from containment unit into on-site treatment unit. So how we can do that? When we look to a pit, usually what really goes to the pit is mostly, more than 95% is liquid. So if we're able to divert or separate the liquid from the solid waste, we can reach both stream, on-site, and simply. We do it through the effluent divergent unit. It's a plastic fitting that can be plugged to any 4-inch pipe. By doing so, we utilize all the existing investment, such as the shelter, the toilet pan, and the existing ring. The EDU itself is fitted inside the pit latrine, so we overcome any behavior change challenge. Now, the EDU will do 2 main things. First, it will divert the fecal waste into pit 1 and reduce the filling rate by 95%, while the effluent will be diverted to pit 2 and received on-site treatment over there. And that's doable because the concentration ratio is very minimal. So here you can see a small system in operation, and I'm zooming in to our primary treatment unit of the effluent. We managed to fit 3 treatment technology in series. We start with a settling tank, anaerobic settling tank with a volume of, with a hydraulic retention time of 50 hours. Its goal is to capture fecal matter or solid and break down or hydrolyze the urine. Then it will be supported or followed with a biosand filter with the goal of reducing the BOD. And finally, we release everything to a leach field. The system footprint area is 0.8 meters square, the size of a washing machine. And the total cost, the whole thing, the EDU and the primary treatment unit for the effluent with the rings and installation is around $40 in Bangladesh. Here you can see some of our parameters, the system efficacy. Before and after the EDU, point 1 and point 2, the EDU have the potential of removing more than 99% of the BOD. Our effluent characteristic at the exit of the biosand filter is 19 milligram per liter. Now, our go-to-market strategy, our goal is to create demand over this product. So we use the existing model of IDE and SATO, where the sanitation entrepreneur is the main player. We use him to mobilize existing resources, such as sales promoter and masons and pit emptier. We started our marketing strategy by going door to door, then targeting marketing approach by marketing session in the bazaar. Right now, we developed some animation that use it on social media and WhatsApp. The potential of the EDU is big. It's pretty much flexible. You can plug it to single-story household, to a building, to a public toilet or pit latrine. Our strategy right now, in the last 2 years we've been working on this, we built all of the product. All the unit we put on the market was sold. But we are doing it without having the credibility. So right now, over this year, we're trying to do it through partners to gain the credibility part. So next month, for example, we are building a unit in Kisumu in Kenya with the help of Kenya Water and Health Organization. So what we have achieved in the last 2 years, we did a good product proof of concept in Jordan, in Bangladesh. Our system survived a strong monsoon season. More than 24 units did survive it, and people saw the impact of it. The proof of market, people are paying for the system, and when they see the value of the system, like it reduced the filling rate, the odor is much lower. And after a monsoon season, the system is still intact and no fecal matter was outside the toilet. This is what we can achieve, maybe another 2 or 3 POC. What we need your help with is how to mass scale manufacturing and do a global scale. This is what we are here for. Me and my colleague, Mandy and Sam, are here. Please raise your hand. Try to find us at any time. And we're more than happy to talk about more pilots and more items on the ground. Thank you. By the way, this is the unit. We estimate the cost of it on mass scale manufacturing like $6.
Fantastic. Thank you so much. I would love to hear questions from you all. I think we have maybe this woman in the center. Oh, great. Yes, Kevin's coming to you. Yep.
Okay, I can go first. Yes, so thank you for the presentation. A quick question about how might you deal with non-fecal waste? When you think about pit latrines, you have diapers, you have hygienic products, you have all sorts of things. And for the past 15 years, there are many groups who have tried to improve solid liquid separation in toilet facilities. So how does your product deal with that?
So for pads, the system can handle them and napkins. If something like a plastic bottle or whatever, it will get clogged. The system is designed here with an like inspection service that you can clean and maintain easily. Simply what we did, up to now, worth to mention, we've been operating for 18 months. We have more than 20 units installed. None of them got clogged. So we just did basic awareness with the people. But what we did in one installation that we created, we inserted 4-inch pipe on the slab so people can inspect it at any point. So that was the approach. But up to this moment, we did not have anything clogged in more than 20 installations in Jordan and Kenya and Bangladesh.
And in what settings was in what kind of settings was the system installed? Because
all in
whether
host
you go
communities.
from household to community scale to schools, you will have different
household.
behaviors.
All of it to household pit latrine settings, rural community.
Thank you.
So you said that the unit's about the size of a washing machine. What is the kind of land footprint required for it? And so I'm just thinking about beyond a rural application into more of a peri-urban or more densely populated setting.
So when we talk about sizing, it's really about the number of users you have per unit. I think for 20 people, it's 0.8 meters square. This is the footprint. The system net area is around 12 meters square, the 3 units you see in Suez. I think we need more testing, but our initial estimation or calculation for hydraulic loading rate is around 12 or 17 liters per meter square.
Great. Yep, we have time for another question.
Wow, excellent presentation. Really interesting. And I'm sorry if I missed it, but have you thought of any purposes what to do with the liquid waste? Like, can it be used for irrigation or even made into drinking water to have like a closed system, or?
So the water depends on the project scope. In Jordan, the goal of the project or the pilot was to harvest water. So we created a pond, and the water was collected there and used for irrigation. In Bangladesh, the goal is just to safely discharge water to the environment. So it depends really on the goal of the pilot.
Thank you. I think you said the cost was $40, but
Yes.
I didn't know exactly that covered which components again.
So the cost is $40. $6. We are selling this for $6 because we estimate the mass production cost is around $2. The retail is $6. We buy 3 or 4 rings. The EDU, the treatment system between the tarp, the sand, and the settling tank, and the installation cost, and this adds up to $40. The point is to retrofit it on existing system. This is why it's 40.
And that includes the
existing lead, yes.
And those two, because it requires 2 pits.
We utilize 1 pit, and then we buy 3 or 4 rings for second pit.
Okay, great. Thank you. We can fit in maybe one more question right here, and then we'll transition to the last presenter.
So when it comes to on-site wastewater treatment, a major issue is what happens to the pathogens. Since human wastes contain a variety of different pathogens, on-site septic systems don't work very well necessarily. So what do we know, or what do you know about the fate of pathogens in systems like this?
So the EDU can enable many things. I'll let you know, this question have 2 parts. When we talk about the chamber number 1, where we have the fecal matter, if there is no water, the fecal matter can get dehydrated in 2 weeks and lose like 60% of its volume. In our operation in Bangladesh, we are using tiger worm, so they're transforming it into vermicompost. With respect to the effluent, even if the effluent gets in touch with the fecal matter for a few seconds, it gets loaded with microbes and germs and gram-negative bacteria. Right now, we design our system to comply with regulations, so this is why we added a leach field at the bottom. We can add chemicals like magnesium oxide and so on to eliminate the pathogen, but it's an extra additional cost. As the system is underground and treated in this way, like we're preventing this, we are not removing the pathogen from the effluent, just worth to mention. In Jordan project, we use the UV light because we had a pond and in the process of sterilization. So we can come with many different combination and treatment technology, depends on the scope of the pilot.
Okay, thank you so much. Appreciate it. Okay, great, thank you. If you haven't already filled out the audience choice, well, you can't submit it until after all the presenters have gone, but you can pull it up and start thinking about your ratings. But we are going to welcome our last presentation, Watson. And yes, thank you.
I'm Chandrasekharan. Yeah, can I do it online? Social enterprise from India. Thanks to UNC, the Water Institute, for giving me this opportunity to talk about the new technology in this session of Technology and Innovation Showcase. We have a new product. This is a nanofiltration method made up of red clay, wood sawdust and sand, molded into desired shape and sintered in a furnace. The pores are nano-sized, which are almost like 1 nanomicron to 50 nanomicron. And these are all like smaller than the pathogens, like 0.2 to 0.3 microns. So the pathogens, heavy metals, turbid materials, color, odor, nothing will pass through this compact nano clay candle, and only water will percolate down in a vessel. So you pour the dirty water on the top vessel what will come below will be pure water. And if you can see these pictures, which is showing this capillary size of 0.2 to 0.3 nanomicron. And these are the holes which are formed while sintering this combination, thereby giving it as a natural purifier, natural filtration process instead of using membranes or cartridges. So there is a top vessel, there is a bottom vessel. These clay candles are fitted into a plastic holder with nut and washer. To just fit it, it's a do-it-yourself model. And to add on to other complexities, we have developed fluoride and arsenic removal filters, which are also nanomaterials made from natural produce. Both the products are being collaborative with various institutions. The fluoride was developed in collaboration with PSG Technology, and arsenic removal was developed in collaboration with IIT Madras, India. In fact, this is the only green product in the nanofiltration process. In replacement to RO, in replacement to EF membranes, there is no electricity, there is no wastage of water, there is no chemicals to be changed, and the candle, if you just clean and rinse wash, can go on and on for any number of years. I myself personally am using it for the past 13 years. In fact, so far we have reached out to 500,000 rural households in India, the bottom of the pyramid. Thereby we had been saving almost 25 kilowatt hour energy per month, thereby reducing carbon emission. We have so far saved 2,500,000 tons of non-electric purification and almost 2 billion tons of carbon emission saved by stopping burning of firewood to boil water. There is no PFAS or anything leached out of this product as against the RO plants, which are the biggest PFA producers and solid waste producers like membranes and cartridges made up of polymers, whereas here the discarded material is just a siliceous nano clay, natural clay. There is zero water loss, hence it is reducing the water stress as well. Most importantly, unlike RO, this nanofiltration retains good mineral and salts, thereby allows you to build immunity and bone. We have done all the ranges of products, starting from a standalone filter, larger community filters of 200 liters, 500 liters, 2500 liters, which are very helpful in putting it in community centers, schools, child care centers, primary health centers, and this meets all the WHO standards and IS 10500 standards. We are the only product being certified by most of the government premier institutes in India, and we have been given various awards from various national and international forums. And I am a fellow of Royal Academy of Engineering, and I got the Innovator of the Year award in this year from the Royal Academy of Engineering, London. I have done 2 TEDx speeches on water and water remediation using natural. And the other collaborator is P.N. Subramaniam, who is also an engineer with MBA in his kettle. And our combined work experience is 100 years in the domains of engineering, technology, strategy, finance and IT. And the biggest strength is the women force we have. All are from BOP families. We have chosen the people from tribal areas and from bottom of the pyramid. We have trained them in both in our factory and in our workshop, who are doing this water purifiers for us. What we seek is collaboration for taking this cost-effective product to all the last mile needy people of all countries. Researchers in water treatment can rely on our expertise in scaling and manufacturing to bring out new technologies which are environmental friendly, join us to mass manufacture, scale and give across the needy product to the world. We are seeking collaborations with philanthropies, companies doing CSR. NGOs can fund us in providing the water purifiers to the bottom of the pyramid families, war-stricken areas, camps, flood and drought relief centers, thereby saving energy, water and carbon emission. Thank you. This is Watson Envirotech Private Limited for you. My mobile number is and my email ID is given here. Any questions you can write to me or talk to me. Thanks for this great opportunity.
Thank you so much. Are we getting virtual questions for him, or I actually don't know if he's live or not?
I'm available.
Oh, you're here. Great. Okay. Amazing.
Yeah.
Well, we have time for one or two questions. We are a little over time.
All right, quick question. So you mentioned the nominal pore size of 1 to 100 microns, but we know that viruses have a length scale of tens to hundreds of nanometers, so thousands of times smaller. So what is the basis by which the technology removes viruses currently, or could some sort of a disinfectant or a UV or other technology be integrated for virus removal or inactivation? Does that make sense?
Good question. What we have done is embedded the clay with some MOF, metal oxide framework, which is actually deactivating the viruses and killing them instantly because it passes through these nanomaterials when it goes down. The candle thickness is almost 2 inches. So when the water passes and percolates, it almost takes 3 hours for 15 liters to go down. So by night when the rural people, they just pour the water on the top, what goes below will be after 3 hours. So morning when they wake up, the whole bottom vessel will be full of good clean water. Because of adding these type of special nanomaterials, we are killing the pathogens, irrespective of whether they are bacteria or viruses. Thank you.
Thank you. Thank you. Okay, we might have to cut it at that just to respect everyone's time for the next session. But thank you so much to every single presenter today and the judges for being here. And a final reminder for the survey, I was told that the questions used to be required and I just fixed that. So hopefully none of the questions are required because there were 2 presenters that could not join last minute. So please fill that out for the ones that you did see. Don't rate ones if you didn't actually see it. And we are excited to host this again Tuesday and Wednesday at lunchtime, same place. You will see fresh new innovations. There are many to cover, so we are super excited. If you have more questions, the Business Connect booth is out there, and we can connect you with who you would like to talk to. Thank you so much. I will let you get going.